Today we're going to be talking about mostly rotational motion, rotational dynamics. We're going to talk about torque in the context of rotational motion, and then with our next week we're going to pick up more about what torque is and how it acts on things and how it comes to play a role in statics. But for right now, rotational motion. So what is rotational motion? Well, rotational motion is movement around an axis. That's all it really is. Right? And so we use several different things to talk about rotational motion. We have our angle theta that we happen to be at during our rotation, and theta is just where are we, right? Where are we? Omega, this funny looking W thing here, right? Omega, that is our rotational velocity. So omega is the rate at which we're rotating. Now the natural units for omega are radians per second. And so we'll use radians per second a lot. There are also rotation per minute, or rotation per second. You think about rotations per minute when you talk about cars. So what is omega? So omega is in the units of radians per second. Well, let's say you need to convert to rotations per second. Well, one rotation is what in radians? One rotation is 2 pi radians. Right? That gets you all the way around once. And so to convert, if you had 1 radian per second and you want to go to rotations, well, you're going to just say a rotation per 2 pi. And then you need to convert seconds to minutes. You're going to need 60 seconds per minute, and now you're at rotations per minute. So omega, angular velocity, right? Omega. You're accustomed to the capital omega. Well, this is just the lowercase version. Omega. Now, what does omega mean in terms of linear velocity and things like that? Well, if we take something that's going around in a circle and we look at what's the velocity of a point out here that's at some radius r, what's the velocity out there? Well, the velocity is v over r, or the angular velocity is omega equals v over r. So omega is v over r. That's simple and straightforward enough. And the way I've drawn it here, this is a counterclockwise rotation, all right? And so by the right-hand rule, which we'll talk about again and again, the right-hand rule, that is a rotation that with a vector for omega pointing out of the board towards you and away from me. Now we get to the most confusing thing about me using the light board technology. This is actually my left hand. So when I talk about the right-hand rule, I have to use my left hand to think about it. All right, so we have this counterclockwise rotation going on. That means it's a positive rotation towards you. It's a negative rotation from my viewpoint over here because it's away from me. All right, the vector is perpendicular to the plane of rotation. It's along the axis, and it is in the direction that your right hand curls your fingers around in the direction of motion.